video, we'll focus on the Pandas read CSV function. In the comments section below, I've included a link to our comprehensive guide that's hosted on GitHub. So for those of you that want to tag along, you can go to and get that resource and then kind of walk through some of the examples that we'll be doing here. So taking a look at our first example here, this is going to be basically just the pure defaults. And if you were to go to Pandas and look at the documentation, this is basically the only example that you would see on the website. Going back to our Jupyter notebook here, I'm going to go ahead and import Pandas as PD. And then I'm going to go ahead and read in the data frame by typing data is equal to pd.read CSV. And then I'm just going to grab that first example that we have here, example.csv. And then to get an output, I'm just going to go ahead and type data. All right, so once that finishes running, you can see we have our name and birth date data set that has the name and birth date of different people here. Now this is the basic functionality of Pandas, and as we go through, we're going to get a little bit more advanced. We're going to walk through all of the functionality that's in the Pandas documentation, and we'll kind of go from there. All right, so our first example was basically just a regular CSV file. It was comma separated, and we're going to start getting into a different example now where we have a tab separated CSV. So taking a look at this next one here, I'm just going to pull up in my notepad the tab separated file that we're going to be working with. You can see there's no commas. Even though it's named a CSV, it still is going to be a tab separated file. So to handle this, let's go ahead and take a look at the example here. We're going to type 2 so that it's example number 2 CSV that we're looking at. And then we're going to use the argument SEP. Now SEP is basically going to allow us to specify the separator. In this case, we don't want to use a comma, we want to use a tab. And so we'll be able to do that here by typing \t with around some quotes, and that should read in the example2 CSV file. Let's take a look. All right, so nothing really changed in the output, but if we were to try to read this example CSV as a comma separated file, it would put basically everything into one single column. And so maybe just to kind of give you guys an idea of what that looks like, let's go ahead and run that. And as you can see, it's in one single column. Right, so putting the separator, let me go ahead and undo this here. Run it again. Putting that separator in there and differentiating what it's going to be doing is a great way to kind of work with different file types that you might run into. Alrighty, taking a look now at example number 3, we have a different type of file, and sometimes this will happen when you're running into data cleaning and different things like that. You might have some odd spacing between your data. Now, Pandas can handle this type of data by using a space function, or a space separator I should say, where it'll basically take all of the spaces and count that as the separator. Now to do that, let's go ahead and close that. I'm going to change this to example number 3 CSV, and then we're going to type \s, and actually a lowercase s there, and then do plus. Now again, when we run that, we get the 2 columns, and just to give you guys a visual of what that looks like if we didn't run it with the separator, we would get everything within one column. Alright, so we're going to move on to the header argument within the read CSV function, and the default for the header is to take the first row and make that the header for the data frame. So let me go back a little bit. We're going to get rid of this separation argument here. Go back to our example, our first one here. So it's going to take that first row of the CSV file and basically make that the header. But you can specify it to be something different. Now this is particularly useful if you have a CSV file that doesn't have headers. So looking at this example, we're going to take the header argument and we're going to pass in none. So basically this is what you would use if you had a file, like I was saying, that didn't have column headers, right? So if it's just straight data, if the first line started with James with the birth date 2000 0525, that would be what you want to use. Let's go ahead and run this and see what happens. So you'll notice in this example, since we specified that there was not going to be any headers, it pushed the name and birth date into the first row. One other example within the header function is, I mentioned you can specify which column could be the header. Alright, so in this case we're going to specify the header as 0, since in Python the counting starts at 0. You can see that right here with how the rows are listed. We're going to say that that first row is going to be our column header section. And again, this is the default, right? But if I wanted to say, maybe I want the first, or in this case the second row, to be the header, we can run that, and you'll see that we have James as the header. Alright, so to handle multi-column headers, we can go ahead and still use this header function. We're going to change our example to example number 4 here. And I'm going to pull it up just so we can take a look at it. So you can see we have demographics in the first row and then name and birth date in the second row. In some cases you may have files that have these multi-header index, or I shouldn't say multi-header indexes, I should say multi-header columns, right? So there's multiple columns that are actually acting as a header. The data is after those columns. So how does Pandas work with that? Well, what we can do, just like we did before, is pass in the specific rows that we want to count as the header. In this case, we're going to say 0 and 1, so that first and second row will be passed in as the header. Now let's see how Python and Pandas spits this out. Alright, so you can see data starts here. Again, it starts at 0 at James like it should. And then you can also see that demographics, even though it was listed twice within the CSV file, has now been put over the name and the birth date. Alrighty, our next example is going to be example 5 CSV. And let's go ahead and I'm going to close this last one. I'm going to open up this file here. Now you can see, like we were talking, some CSV files do not have headers. In this case, this one does not. So what we want to do is practice an example that reads this in successfully. If you're working with real live data, you obviously want to make sure that you're doing the right thing. Alright, so we're going to use the name argument to make that happen. So I'm going to type name, and then I'm going to specify what the names of those columns are in a list format. Alright, so I've got 2 columns. I'm going to name the first one name, and I'm going to name the second one date of birth. Now I mentioned before that the default would be to set the first row to the column headers. But in this case, since we're passing the name function, what it's going to do is assume that there is no header, and it's going to replace the header with these 2 objects here. So let's take a look and see what happens there. Oh, I made a small mistake there of saying name. It is actually names. Go ahead and run that again. And we have our data frame once again with the name and date of birth of these people. Alright, this next example is example 6.csv, and we're going to have a little bit more information here. So we're starting to see this data take shape. It now has an employee number, a name, and a birth date, so you can kind of have a few different data points there. What we're going to do here is pass in an index. So you can see on our example over here, let me move this out of the way, you can see that our index is 0, 1, 2, 3. That's a default that Pandas does when you don't really have an index. However, we can pass our own, and in this case, an employee number, this first column here, would be a great index for that. So let's go ahead and practice. Alright, so I'm going to go ahead and type out index column, COL. And in this case, I'm just going to specify what the column is that we want to use as our index. And once again, that would be the first column, or in this case, when you're counting in Python, it's going to be 0. Alrighty, I need to change this to example 6. And when we run that, you can see that we get a nice index based off our employee number. Alright, so we just recently talked about how there can be multiple headers within a CSV file. Well, there can also be multiple indexes. We're going to look at an example of using a multi-index with our next one here. Alrighty, so you can see our example 7.csv has another column in it called department number. So we're adding this in front of the employee number, and what we're going to do is make a multi-index. Let's go ahead and do that. So we're going to pass in example 7 as the CSV, and just like the column headers that we did earlier, we're going to go ahead and pass in a 0 and 1, indicating that we want the first and second column to be our multi-index. Let's go ahead and see what that looks like. Alrighty, so just like before, we have a department number and employee index now, so multiple indexes, and you can see that it's spanning over the 2 rows that have the department numbers, and it'll do that, throughout whatever you specify there within the CSV file. Alrighty, this next example is going to use that same example 7.csv, but we're going to look at the use calls argument. So that is use COLs argument, and what we're going to do with this one is pass in the columns that we want to include within the data frame. So this basically allows you to filter out unwanted columns that you don't need, through this quick little argument here. So I'm going to type out use calls, and we're going to specify the names of these. So we're going to say department number, and once again this is going to be in a list format, so I'll have to do some commas and create it into a list here. Alrighty, so now that we've specified our columns, you can see that we are not going, in this one, we're not going to be including the employee number. Let's take a look at what that looks like. Alright, so we're back to a basic data frame, but we've been able to select which columns we actually want in the data frame, which is pretty cool. Alrighty, this next example is going to deal with columns that have the same name. Alright, so let's take a look at our example 8 CSV file here. You can see we have department, employee number, name, birth date, and a second name column. Now, when you're working with different columns, obviously you can't have them be the same name, right? And so Pandas has built in some functionality on how to handle these. Let's go ahead and take a look at what it does when we pass in this example 8 CSV. I'm going to get rid of this argument here from our last example. Just pass in example 8, and let's see what happens. Okay, so you can see right away that it took the second name file and put a .1 after it to specify that it is a different column. Now it's interesting in the documentation of this version that we're working in, as I was reading through it, part of the functionality is to say if you pass in false into the, and I should have specified what this does, this argument. Let me pull it up here. This mangle, let's see if it will autocomplete here for me. So this mangle dupe columns, if you pass in false, the default is true, and that's why we have the name.1 here. But if you pass in false, what it's supposed to do is take the second column and replace the first, right? So when I do that here, I actually get an error. And I'm wondering if this is just maybe a functionality that wasn't fully finished. Maybe they're still working on it. But just so you're aware, the default for this argument, and something that you don't really have to worry about is passing because it's already the default, is true. It'll automatically take that second name column if it's named the same as the other column, and put a 0.1. If there's multiple after that, it'll do 2, 3, 4, etc. All right, so that last example is pretty interesting. We're going to now talk about the dtype functionality that's within the read CSV argument. To kind of illustrate this, let's first take a look at the default of what it's going to do when you just read it in normally. So let's go ahead and just alter this a little bit. We're going to say dtypes here so that we can kind of see what type of data types we're getting as we read this in. So you can see department number, employee number are int64 data types, and then name and everything else is an object, or that can also be interpreted as basically a string. Now, when you read in data, you can change certain data types so that they read differently. So if you don't want department number or employee to be an int, you can change that. And we're going to go ahead and try an example like that right now. Okay, so to do that, you're going to type comma dtypes, and I'd recommend again, and I'm sorry, it's not dtypes, it's dtype. A little bit of confusion there with the dtypes on the actual data frame. They do name it differently, so keep in mind that that's how you're supposed to do it there. Moving on, you're going to want to pass in a dictionary of each column name and their new data types that you actually want to read them in as. So let's go ahead, and I'm actually going to copy and paste this since it's going to take a little bit more time to write out and I don't want to bore everyone to death here. So let's go ahead and copy and paste in the department number and employee number, and we're going to pass them in as a string using this dictionary. Let's go ahead and see what happens when we do that. All right, so there we are. We have the department number and employee number now as strings, or in this case objects, within Pandas. All right, so staying on this topic of changing data types as you're reading in data into a Pandas data frame is a parseDate function. So we have birth date over here, and we don't really want to keep it as a string in this example. So what we're going to do is we're going to say parseDates, and then I'm going to pass in the column name. And you can do this with multiple columns if you have a bunch of date time or date objects that you want to have in Pandas. You can just pass it in the parseDates function, and it should spit back as a datetime object within Pandas. So running that again, you can see we now have the datetime 64, and it's changed from that string that was previously on there. All right, this next example is looking at skipping certain rows that are in the CSV file. So kind of an interesting one, and maybe not one that you'll use a lot, but could come up when you're doing some data manipulation. We're going to go ahead and use the skip rows argument, and we're going to pass in some rows that we want to skip. So I don't want to skip the first row since that's going to be our column header, but I'm going to go ahead and skip the second and fifth, and we're going to see what that brings back for us. Oops, let me change that, get rid of the data types, or dtypes. All right, so we have department number, employee number, name, birth date, everything we had before, but now we don't have as many rows as we had previously. All right, similar to this functionality, there is a skip footer. There's a skip footer argument that allows you to skip the last X number of rows. So in this case, I'm going to skip the last 3 rows. And again, we're going to use this example 8 CSV file here. Run that. We can take a look at the data frame now, and we have the last 3 rows no longer within this data frame. So again, just another way of skipping rows. All right, once again, there is a similar type of functionality that you can use to only read in a certain amount of rows, and that is the nRows argument. So in this case, this is usually for files that are very large and you only want to get a certain amount of rows within that file. What you can use is this number of rows functionality. Let's go ahead and pass in 500, and then we're going to change this to example 9. So you can see we have a few more rows here, about 8,000 or so to be exact, and what we're going to do is just read in the top 500. So that's what Pandas is going to do with this nRows function. Let's go ahead and see what happens. All right, so this is the functionality. Basically just allows you to read in those first 500, and you can see it successfully did that. Alrighty, we're going to go ahead and use another functionality called the NA values. And I'm going to pass this argument in. We're going to say NA, and there's two there. You can see there's filter and values. We'll get to filter in a minute. So for this functionality, we really need to look at what you might run into when you're actually needing to use this. And I'm actually going to go ahead and search for the Pandas read CSV documentation here. All right, so looking at the documentation, you can see there's a few things here. Initially, it's a little bit confusing, so just to break it down, what Pandas is going to do is take well-recognized and known NA formats and automatically make it a NumPy NaN value. Okay, so let's take a look at our example data that we have. In this case, what I've done is I've created a not so known NA value, so I put hashtag no data here in some of these spaces, and since that's not a default, I'll show you what happens when we read it in without any NA values passed here. So let's take a look. Need to change this to the 11. All right, so you can see that it basically just passes this in as a string, and it doesn't have any real NaN values that are understood by Pandas, right? So what we can do is add to that list by saying NA, once again get the values out here, and then what you're going to do is pass in your customized string that indicates that there is basically no data. So in this case, no data, and then when I run this again, it's actually going to spit back out the NaN values, or at least it should, fingers crossed. All right, so there you go. Because it wasn't in the list of already known NA values, you can pass in your own and it'll do the exact same thing that it does automatically. Alrighty, we're going to look at a new example here. Let's open up this data. So you can see that we have a hashtag NA value. Now, as I mentioned in the last example, that would be one that's recognized by Pandas and would automatically translate into an NaN value like we saw here. What we can do if we don't want it to automatically fill with a well-known NaN value or a standardized NaN value is we can pass the argument keep default NA. So let's go ahead and do that. Now this one's kind of confusing because keep default NA is automatically set to true, but in this case we're going to need to set it to false in order to get it to not read in the NaN values and to read in the hashtag NA values that we see in our other example. So let's take a look. We're going to go ahead and pass that in the example 12 CSV and we should be good to go. Okay, so again, just to visualize this, and got to pull up the right one here, you've got this example 12 CSV that we just ran, and once again these would automatically be translated into an NaN value, but we passed the keep default NA to false so that it would basically read it in as it was. Alright, this next example is looking at blank lines that may occur in your CSV files. Now let's take a look at what it does by default if we just have these blank lines within Pandas. I'm going to go ahead and run this, and it looks like it interprets blank values as spaces that are dead, right? So it's doing essentially automatically what you probably would want it to do, where it doesn't take these spaces and pass them in as like NA values, but it takes them away and gets rid of them. Now, for whatever reason, if you wanted to have these spaces kept in there, you could pass in the skip blank lines argument and override the default of true. Now let's see what happens. Alright, so it took those spaces and filled them with NaN values. Again, maybe there's a reason why you'd want to do that, but one of the nice things about Pandas read CSV function is it does a lot of this data cleaning. Alrighty, we have covered already so much of this function. That's pretty much all I had for now. There are a bunch of other functionalities that I haven't gotten to, but these are the main ones that you'll probably use most often, and hopefully this was a pretty comprehensive guide for you guys to really dig in and figure out how to use the Pandas read CSV function. If you liked the video, please subscribe to our channel, and we'll see you at the next one.